All right, so let's go over these problems and see how we did. And we're also going to learn something new with going over these. So the first one we have here is carbon and bromine. Now at this point, you're probably pretty good at figuring out that carbon is going to be the central atom if it's around. All right, if not, no big deal. You could always, continue to draw the dots and see that, okay, there's 4 dots around here. It's not a dot. And then there is, bromine has 7. All right, so it only has 1 electron for bonding. Carbon has 4, so carbon's going to be our central atom. All right, let's put the bromine around it. Okay, so there's our bromine. Carbon's all around it. And for this one, we can look at our electronegativity chart, check out bromine, and see that it's about 2.8. We can see carbon is about 2.5. So the difference between those is only 0.3. So that means that it's not strong enough to be polar. So we're going to write over here nonpolar. Now there's another reason that it's nonpolar, and we didn't even need to look it up. Notice that there is a bromine on all 4 corners over here. So it's kind of like, even if it was fluorines, they're all going to be pulling in opposite directions, and that's going to cause them to cancel out. So even if this was all with fluorines, and fluorine's way more electronegative, it would still end up being a nonpolar molecule. All right? All right, so let's do the AXEs. So we have carbons in A, the bromines are all X's. So this is going to be AX4. The shape for AX4 is tetrahedral. And we have the bond angle of 109.5. And the Lewis diagram, the final cleanup version, is going to look very similar to this one. It is just going to be C, all the BRs around it, and then 6 electrons around each bromine, because 2 are involved with the bonding. So we have 6 around here, and then we have 2 involved in bonding, so that gives us our 8 electrons. All right, any questions with that one? Okay, so if we take a look at the next one, we have C, again carbon, and then hydrogen and fluorine. So if it's group 1 or group 17, so if it's like hydrogen or if it's a halogen, the carbon is going to be the central atom, right? Because it has 4 electrons that can be involved in bonding. All the other things only have 1 electron involved in bonding. And now here's the new thing that I haven't mentioned before, but will make the test a little bit easier when you're answering these kind of questions. You always want to put the similar atoms next to each other. So for example, this hydrogen, if you put a hydrogen on the top, you have to put the other hydrogen on either the left or the right side. All right, and then the fluorines are going to go in the other spots, and they're also going to be next to each other as well. Now you might be wondering why, which is great. Like, why is that? Why does that matter? If you always put them across from each other, they're always going to cancel out, right? And then that's not going to give us a true representation of whether or not this is polar. So we want to make sure that we arrange it this way so we can see, is there going to be a pull on one side or the other? Now, if you're like, well, what actually exists? Well, they both kind of do, because remember, this is a 3-dimensional shape. So if you rotate this, you can look at it in such a way where they're across from each other, or you can rotate it in such a way that they'll be near kind of like each other. But however you hold it, there'll always be one side of it that'll have all the fluorines, and then the other side of it that'll have the hydrogens. So drawing it this way is kind of the best way to represent that there is a divide between these two right here. All right? Okay. Let's do all the AXE stuff, and then we'll jump onto the other side to figure out if it's polar or not. So first of all, we have an A, X, 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 X. Just like above, it's going to be the same. It's AX4. It's going to be tetrahedral. 109.5. All right, and then let's draw the final version of it. So we have C. All right, I'm going to change the color so we can talk about the electronegativity. And here we have 2.1. 2.5 for the carbon, and then 4. So the carbon to the fluorine, that difference is 1.5, which is polar. And they're both going towards this side where the fluorines are. And then the hydrogens, they're going to be going in this direction towards the carbon. So we can see that all the arrows are sort of kind of pointing towards this side of the molecule. So this side over here is going to be slightly negative. This side is going to be slightly positive. And it's as if we're dividing it in half kind of through here. So the hydrogen side will be positive, and then the fluorine side will be negative. Now, if you put the fluorines across from each other, it would make it look like it's nonpolar, which again would give us the wrong answer for this. This is going to be polar. Okay, now we have nitrogen diiodide. So nitrogen has 5 valence electrons, so you can bond 3 things to it. The iodine is a halogen, so it can only bond to one other thing. So we need to make this nitrogen the central atom, and then we're going to bond the iodines to it. Everything looks good. Great. We can figure out some shapes and whatnot for it. So let's do the AXE first. We have an A. We have some X's. We even have an E in this one. So it's A, X3, E. The shape for that is trigonal pyramidal. Trigonal pyramidal, and the angle is 107 degrees. All right, and this looks pretty good for our final version, but I'm going to draw it again over there, so we're going to add the dipoles if necessary. So we have N. All right, nitrogen is 3, I think. 3.0. The iodine is 2.5. So we can see that it's going up in this direction by 0.5, so that leads us to believe it's polar. These two are also moving towards the nitrogen. So you can think of them as canceling out, but what the molecule actually looks like is sort of like this. So all of them are moving up towards the nitrogen. But again, even if you drew this at 90 degrees and you're like, okay, these two I's cancel out, you would still get the right answer, because you would still say, okay, this I at the bottom, it's going up towards the nitrogen. So that's going to be the slightly negative side. So either way you do it is fine. All right, and that's going to give us slightly negative, slightly positive, and polar. All right, cool. All right, last one. We have oxygen and chlorine. Again, chlorine's a halogen, so it's only going to have one thing that it can bond to. So oxygen is going to be our central atom. Chlorine, I'll put one over here. We'll connect them, all right? So that looks pretty good. Let's do the AXE for it. So we have the A is the oxygen, the chlorines are the X's, and these electrons are the E's. So we have AX2, E2. The shape for this is bent, and the angle is 104.5 degrees. Okay, so let's figure out the electronegativity of it. So we have oxygen bonded to 2 chlorines. All right, oxygen's number is 3.5, and chlorine is 3. So they're close, but when you do the subtraction, you'll see that, all right, this is 0.5 going towards that oxygen for both of them. So that's going to make it polar. So this is going to be slightly negative. This over here is going to be slightly positive. And this will be a polar molecule. All right. Any questions with that? Nope. All right, cool.